And let's see. From what we did last time, it was a little busy. I had to help a decent amount of people. So I didn't get through all of this AP free response questions. I think I did 4. So I wanted to finish these off today. I think there's only 2 more. And who knows how long that's going to take. And after that, I think I said in the title, I'll go over quadratics. And this is specifically from an IB perspective. But, you know, not that it's exclusive to IB quadratics, but I'm going to go through a package that I gave to my students just because I don't think 2 questions will fill up the entire streaming time. But yeah. So I think I finished this one. And then we just move on to the next, which I have right here. Oh, and then I checked out this guy. RGPT had mentioned that there was this Japanese guy who also does math help. So I recommend, you know, if you're following this channel because of math and not for other reasons, like I'm your teacher or something, then maybe you should follow that guy too, because he seems super cool. Anyways, okay. Let's see what this is about. So R is this region enclosed between 2 graphs, G, H, the y-axis, and the vertical line here. Okay, so one of these is G, one of these is H. Okay. Find the area. Okay. This doesn't seem too bad. We just need to take the integral from 0 to 2. And then I need to know which one is... This one is G, and then this one is H. And the reason I know this is because this shape right here is not going to be a parabola. So what we do is we are going to take H and we are going to subtract G. Okay, here we go. So 0 to 2. 6 minus 2 x minus 1 squared minus negative 2 plus 3 cosine pi over 2x dx. Hello, Choco Chimps. Okay, oh boy, here we go. I need more room for this. Alright, let's just integrate this one thing at a time. So I'm going to integrate h first. So this is going to be 6x and then minus 2 over 3 x minus 1 cubed. And then that's from 2 to 0. And that seems about right. And then we're going to subtract negative 2x plus sine pi over 2x, and then coefficient needs to be 3. So 6 over pi. I'm skipping a couple of steps just because I don't want to do like basic integrals. For example, if you're really stuck with this one, technically it's like a u substitution, and then you would get this point here, and likewise you would possibly need to do u substitution here, which results in this. What a u substitution is it's essentially like a integration chain rule. So if you can just think about what the chain rule should be, that if I were to take the derivative of this and then end up with the resulting function, then you can do that too. You don't necessarily need to do a u sub. So for example, I know that this is an exponent of 2, so it needs to be an exponent of 3. And I would need to chain rule this, but the derivative of this inside part is just 1, so it doesn't really matter. And again, I need this to be a coefficient of 2. And I know I'm going to be, you know, quote unquote, bringing down this 3. So I need a 2 over 3 so that the 3's cancel out. Then very similarly, we have this. So from here, we can just evaluate everything. So we have what? 6 times 2 minus 2 over 3, 2 minus 1 to the power of 3, subtract, and then I need to substitute in 0. And then I need to subtract the other one from this. So minus 2 pi over 2 times 2, subtract 6 pi of sine 0. Sure, okay. Okay, I think I plugged these in properly, so we can just make things look good. So 6 times 2 is 12. And then this is going to be minus 2/3. This will be minus another 2/3, I think. Minus negative 4. All of this stuff is 0. And then over here we have sine pi, which is just 1, so then this is just going to be 6 over pi. It's kind of an ugly answer. So what do we have? I have 12 plus 4 minus 4/3 plus 6 over pi. And I don't know the expectation on how simplified they want it, but I'm not gonna do that because that's just a practice in fractional work. But here's an answer, which hopefully is correct. And if it is, then we move on. And if it isn't, well, we'll see later when we check back with the answer key. So part B, let's see. This region is the base of a solid. And then for the solid, at each x, the cross-section perpendicular to the x-axis has this area. Find the volume. Hold on. For the solid, at each x, the cross-section perpendicular to the x-axis. So at every x, oh, so like we have obviously a 3D shape because we're talking about volume, I think. So each cross-section has this area. Then we need to find the volume. How is this related to the first part? Don't you just take the integral from 0 to 2 of your cross-sectional areas, which was 1 over x plus 3? I noticed this. Every once in a while, they seem to ask a question like later in the question, like a part D or something that's like not even related to the rest of the question. But I'm pretty sure this is it. So, well, okay. Whatever. Let's just evaluate this. This is natural log x plus 3 from 0 to 2. So we have what? Natural log 5 minus natural log 3. Looks suspicious, but oh well. Write, but do not evaluate the integral expression that gives the volume of the solid generated when R, the region, is rotated about the horizontal line y equals 6. Okay, so let me get rid of all this extra drawing. Where's 6? So we have 1, 2, 3, 4, 5, 6 right here. And then we rotate the shape around to make a 3D shape. Okay, this is looking kind of ugly, but it's a volume made from rotating a solid around. I don't know if you can actually tell from my drawing right now. It's normally better than this, but on a pad it's a little more difficult. But this should be pretty straightforward. Essentially, we have a radius of a solid, and then we just integrate from 0 to 2. So let's see. With the y value here at 6. So what we can do is we do kind of like a subtraction where we take a volume of rotation if it only had this, which I think is G. So we find the volume of rotation of G around, and then we basically subtract this little hollow piece, which is the volume of rotation from F. So if we integrate the volume of rotation of F, we essentially find the volume of this little hollow piece. And then if we integrate the volume of rotation of G to 6, we'll get like the entire solid, and then we subtract the hollow piece. So in other words, this might make more sense if I just write it out. Okay. So the integral is from 0 to 2. And then it goes pi r squared, right? So pi, and then the radius of the first one is g of x minus 6 dx, and then we are going to subtract 0 to 2 of the inner volume of revolution. Oh, and this needs to be squared. And then f of x minus 6 squared. And as long as this is the correct formula, which it might not be, I think this is it, right? They don't want you to evaluate it. Yeah. So again, just to repeat myself, we find this volume of rotation. We take g, and then we subtract 6, which gets you the radius. And then you rotate it around and integrate. And then we subtract this hollow piece, which is the integration between what is called h and 6. So then here you go. So let's just draw another picture for emphasis here. What does G even look like? So G, and then here's 6. This isn't to scale. It's going to get rotated around. And then of course we subtract that inner piece, which was F. Which kind of look like this. And again, here's 6. So we rotate this around. And then the resulting volume would be R revolved around. So hopefully that makes sense now. And, last question. So let's see. F, G, and H are twice differentiable functions. Hi, Jazz. And then we know that both g and h at 2 are equal to 4. And we have a line. And then this line is tangent to both the graph of g and also h at 2. Okay, so before we even get started, this line, which has a slope of 2 over 3, this is going to be tangent. In other words, the tangent slope of g and also at h at 2 is the slope of this line. So let's just keep that in mind as we go forward. Okay, so let's see. Find h prime of 2. Well, there you go. It's 2 over 3. And then we now have, let's see, a is going to be another function where we take 3x cubed, multiply it by h, and then we need to find out an expression for a prime, and then also evaluate a prime at 2. Okay. So let me just write that here. Yeah, well, it's no rush. You can eat your dinner. Okay, to take this derivative, then we need to take the derivative of here. And then this is essentially a product of 3x cubed and h, so we're going to use a little bit of product rule. So let's take the derivative of 3x cubed first, which is going to be 9x squared. And then this is just multiplied by h. And then we need to do the product rule. So I take 3x cubed, and then I multiply this by the derivative of h, which I'm just going to write as h prime. So there's your expression for a prime of x. And then we need to find a prime at 2. So we just plug in 2. Into our expression. And then we can evaluate this. We know what each of these values are, h of 2 and h prime of 2. They were either given to us before or we figured them out. So we know everything. So 9 times 4 times 4 plus 3 times 8 times 3 over 2 or 2 over 3? 2 over 3. Okay, let's see what this is. 16 times 9 is 144, which is the first bit. And then we're going to add 16, which is 160. So there you go. That's a prime at 2. Oh, speaking of emotes, today is my last day as an unaffiliated streamer. I finally reached enough followers, enough hours, and enough days of streaming that I can become an affiliate, which lets me unlock the subscription thingy. So basically, people can subscribe to me, and I'm allowed to have one custom emote for people who I can't speak right now. Subscribe to my channel. Yeah. And as the channel builds, I get more and more exclusive emotes that people can use. And I gotta think about this. Thanks. I don't know. I'm going to give this some thought. I don't even know who's going to bother to subscribe. Alright, let's see. H satisfies this. And then we know that the limit as x goes to 2 of h can be evaluated using L'Hopital's. I believe so. If you have Amazon Prime, then I believe your account lets you have one free subscription. But otherwise, yeah, I think it's a paid service. And then I get part of the proceeds. I think it's like $5 though. Per month. Anyways, and then we need to use this limit here to find the function f at 2 and f prime at 2. Yeah, so my next stream on Thursday, I think I will be an affiliate, so it's not a big deal. And then f is in here. So we're going to essentially work with this limit and work with L'Hopital's and try to find out what f of 2 and f prime of 2 is. Okay, so first let me write this down. The limit as x goes to 2 of x squared minus 4, 1 minus, I'm going to shorten this to f of 3. Okay, so here's this limit. This is for h. And then essentially this should be equal to 4 because we know that h of 2 is 4 and we also know it's differentiable, so that essentially means it's continuous at 2. So the limit as we go to 2 should also be the value of h at 2. So I know that this thing is equal to 4. Oh, I guess I'll, and then this is for f of 2. So let's get rid of the limit. I can evaluate the limit essentially. So f of 2, and then I guess this is also 2, but then that would be 0. You know what? Let's just leave it like this for now. But okay, let's do some solving then for f. You know what? I'm going to put 2 in here. So this implies x minus 4 is equal to 4 times 1 minus f of 2. This thing is cubed. And then we try to solve for f. This is an unusual question. I don't think I've ever seen something like this before. So divide by 4. This is 1. And I'm curious what the answer key is going to say. So f of 2 is equal to the cube root of 1 minus x squared minus 4 divided by 4. But then this is at an x value of 2, so then this thing is going to be 2. And all of this is 0, so you're just taking the cube root of 1. So this is just 1. Sure, okay. Let's go with that for now. So again, I changed my mind, and then I'm going to evaluate this at 2. This feels so sketch to me. Hold on. If I evaluate this at 2, then I get 2 squared minus 4, which is 0. But the limit is 4. So that means that... Oh, right. This is... You can use L'Hopital's rule. So this is indeterminate. So because I know that this is 0, this essentially implies that this is equal to 0. So we can more or less just skip all of this extra algebra work. And then, you know what? Okay, so by L'Hopital, or not even by L'Hopital, but 2 squared minus 4 is equal to 0. So this implies that the denominator, f at 2 cubed, I'm going to put it here. That looks kind of weird, but also needs to be 0. Otherwise, there's no way that your limit could be 4. Yeah. We still get the same answer, of course, but I think this is a better way to logic around it. So that means that f is 1. F at 2 is 1. Okay, so we found that, and then we need to find f prime at 2. So essentially we actually do L'Hopital on the limit. So x squared minus 4, 1 minus f cubed. So up top we have the derivative to x, and then on the bottom we have 1 minus 2 of f, oops, not 2, 3. We bring down the exponent of 3, multiply it as a coefficient, and then it's f squared, and then chain rule with f prime. Okay. And again, this thing here is the limit of h. And then if you do L'Hopital's, then this thing here is the limit of h prime, I believe. So we know that this is equal to 2 over 3. And it's similar reasoning as to why we know that this is equal to 4. This is why they mentioned it's twice differentiable. So we know that the limit as h prime goes to 2 should also be equal to the value at h prime at 2. Okay, and then we can evaluate this limit. So 2 times 2 over 1 minus 3 times f at 2 squared times f at prime at 2 should be 2 over 3. And then we know what this value is now. That's 1. So then we can just do a little bit of algebra and figure this out. This is an interesting question. So this is 1 minus 3 f prime. I'm going to shorten it to f prime. Okay, algebra time. 4 over 2 over 3 is 1 equal to 1 minus 3 f prime. So this is 12 over 2, which is equal to 6. This is equal to 1 minus 3 f prime. So 3f prime is equal to -5. So f prime at 2 is -5 over 3. Okay, and this seems reasonable. I think I did this one right. Okay, and then it is known that g is less than h between x values 1 to 3. And then k is another function that's always in between. And then, is k continuous at 2? Justify your answer. Okay, so let's see. This is pretty obviously going to be a squeeze theorem type of thing. So we need to show it's continuous. So that requires a couple of things. First off, I think this is question D. We need to show that the limit as x goes to 2 of k is the value of k at 2. Okay, so first off, two things. I don't know where he is. But if you're getting network errors, I don't know. That seems like it's on your end. Maybe your computer sucks or something. Okay, well. Well, we know that this is true. So that means for the x value of 2, then g of 2 needs to be less than k of 2, less than or equal to h of 2. And we know that this is a value of 4. We are trying to find out what k of 2 is, and we also know that this is a value of 4. So if k of 2 is in between 4 and 4, then, well, k of 2 is equal to 4. Okay, so we know the value of k of 2 is 4, and then now we need to calculate the limit, but it's the exact same thing. The limit as x goes to 2 of g of x should be equal to or less than the limit as this goes to 2 Okay, so essentially it's the same thing. If these guys have this inequality, then of course their limit should also have this inequality. Now, because f and g are differentiable, then that means that their limits for g and also for h are going to be their values at 2. So in other words, this is 4, this one is 4, right here, and then let's just quote squeeze theorem. So by squeeze theorem, limit of x to 2 of k is equal to the k value at 2, which is 4. So k is continuous at x equals 2, and then we're done. I think that's what they wanted us to show, right? Yeah. And we justify our answer, which is this entire thing. And then there we go. Ah, finally done. That was way faster than Thursday, getting through 2 questions compared to 4 questions. All right, so let's see how well I did. Hopefully, I don't ever hope for perfect. I honestly don't think that this is perfect, but I'm sure it's very, very close to being perfect, which is enough for me. So let me open up the answer key. I think it's this one. No. Here it is. Did you start your homework yet? Okay, number 1A, 153, answer key, 153, nice. Number B, 30, actually wait, no, hold on, I don't think that's the full answer. 6, and then over here, 6, more or less. There's so many questions? Yeah, then you should get started. And then C, when is the greatest number of fish greatest? 6.2 seconds, right here. Let's see, 6.2 seconds, that looks good, nice. And then D, E prime at 5 minus L prime at 5 is negative, so the rate is decreasing. And then they say the exact same thing here, so that's good. Oh, nice. Perfect score for the first question. Okay, part 2A, justify. All right, so this one we needed to quote MVT, which I did right here. And you can see they quote MVT right here. They have the 55 minus 55, which equals 0. Exactly the same as mine. Nice. And then part B, it says use the trapezoidal sum. Oh, I remember this one. So here was the sum, and then I actually didn't even bother calculating it. And then I actually used the answer key, so it's going to be the same. But let me just see if my expression is the same as theirs. Right here, I think. Yeah, we have the exact same expression, so I should have gotten their answer, which is what I used. So that's good, 40.75. Part C. Find the distance traveled. I said 106.1. So here's 106.1. That looks good. Part D is the distance between them. Which is over here, 5.51. And then theirs is a little different. It's 5.1. It's probably some calculation error. but I have the exact same numbers, so I don't know what happened. Calculator error, probably on my part. Oh well, that's pretty good still. Okay, let's see. I need to find the value of this integral. And then I have this, and then they have something different. They have 9 pi over 4 minus 4. I have the 9 pi over 4, but mine is minus 2 and not minus 4. So let me see where I went wrong here. Okay, so I have this here. That's this part. But they also have a 2. And I'm missing a 2. Wait. Oh, I forgot to add a 2. Okay, so this is my mistake. I forgot to add a 2. I remember this. So this 9 minus 9 over 4 pi, that's the area of that piece under the quarter circle. That's this area right here. And then the 2 comes from this area, which I forgot to include. Shoot. So this plus 2 will change this to essentially a minus 4. So this is probably going to affect the rest of my answers. Oh well. So part B, I have 2 root 5 plus 2, and they have the same thing. Okay, that's good. And then part C is a justification. So as long as you justify, I think it's fine. What do they have? Their maximum is at G5. And I think I also said the same thing. Of course, my value of G at 5 is a little different, but it's still larger than 1/2, 1/4, and 0. Which is exactly what they did here on this table. So that's fine. I mean, I don't know how they get marked, because that might not be exactly correct, but oh well. And then part D. Find this limit. Oh, I did it over here real quick. 1 over 4 minus pi. And then I have something different. Is it different? I can't tell. Are these equivalent? Hold on. So this is their answer. And are these two, my answer and theirs, equivalent? I feel like they are, but they might not be. Hold on. Let's just try to make this look nice. I'm going to add these together. Yeah, they're equivalent. Okay, so my answer was good. Nice. Okay, so a couple marks off for the second one, but that's okay. Because I believe the math that I was explaining is correct, which is what really matters. All right. And then number 4, part A, negative pi over 5, negative pi over 5, so that's good. And then I have a decreasing function, and there's an increasing, so something went wrong here. So what did I do? I needed to take the second derivative, and then I plug it in. So they take the second derivative. Okay. Oh, shoot. Okay. So yesterday, or not yesterday, Thursday, when I went through this, if you want to take the derivative of this, which you need to, you need a chain rule, because h is not just a variable. I forgot. This is a function of t. In other words, you should have multiplied this by h prime at t. And then I think you already know what h prime at t is, and then that adds another number here. And then this leads to all of this being positive, greater than 0. So then it's actually increasing. Oh, our GPT is here. Okay, let me finish checking this exam, because I think I'm pretty quick, and then I'll help you with your question. Two of my regular viewers are here. Maybe 3. I know I have one person that generally just lurks. Okay, so I got B wrong, and then I explained why. Will that affect my C? So here was my C, answer for C. And then here's their answer for C, exactly the same. So that's good, not bad. Okay, part A, they do the same integral as me, but they get this answer over here, 44 over 3, which I don't think I got. I got this. So something went wrong somewhere. I'm not exactly sure where, but oh well. The method was right, and then I knew I'd probably mess up plugging in the numbers. Let's see, part B, did they get natural log 5 minus natural log 3? They do. And then here's their expression for the last question, which is essentially the same as mine. They have 6 minus the function, whereas I have the function minus 6. But because we are squaring it, it doesn't make a difference. I mean, will they take off a mark? I don't think so, but oh well. Okay, 2 over 3, 2 over 3, nice. 160, 160, good. And then f of 2 is 1. F at, well, the limit of f of 2 is 1. Okay, so everything is good. And then f prime is negative 1/3. I have 2/3, so something went wrong here. So what happened? Oh, I did my derivative wrong. Oh well. So this derivative is wrong. That changes my answer. It should be negative 1/3. Because you can see if you take the derivative of 1 minus f cubed, you shouldn't have a 1. Because that goes away. So that probably, yeah, changes my answers. And then the bottom one I know is right because it's squeeze theorem. Nice. So overall, a couple of marks off. I'm sure I'm in the top percentile still, which is all that matters. Okay, so time to help Jazz with her question. So the question is, you have a function g. And then we want to find g minus 1 I'm assuming it's this. Is this right, Jazz? Okay, so you need to remember what this little minus 1 means. This is the inverse. In other words, this value is the output of your function. So essentially, what you're trying to do is this is saying to solve for x. So you're trying to find out what x value, when you plug it in to the original function, gives you a result of 4. So hopefully you got that far. Yeah, but you're being overly pedantic again. RGPT. Okay. Yeah, it is important. But I think, I don't know. At the level of her course, I don't know if it's that pedantic here. Or that important, being that pedantic. Yeah. But we'll get to that when we get to that. Anyways, so Jazz, here's your function. You plug in an x, and then you get some g value, some output. So what this is saying is, we know what the output is, and then we need to find out what the x value is so that we get 4. So this statement here is exactly the same as this in meaning. And yeah, you might not want to call this technically an inverse. You can call it a pre-image. But essentially it just means find the x. Yeah, it's an inverse in the case, because I'm sure it was a proper function, and it was 1-to-1. But anyways, you need to solve this equation here. And then, are you allowed to... I'm assuming you're allowed to use a graphing calculator, because I don't see a particularly algebraic manner to look at this, to solve this. You're not allowed to use a calculator. No calculators, no formula sheets. Even for your practice? Okay. All right, time to solve this manually. So we'll see what we can do. Maybe RGPT can help too. But he's got his own homework to do. If you find the inverse first, then that's essentially the same as finding x. So, yeah. Anyways, honestly, this one's a little tough, but if you look at it from this perspective, you have I'm gonna move the 3 over, so you have 1. And, like, honestly, you just kind of need to know how to solve this by looking at it. There's not too many choices because of e to the x, because this is going to lead to a lot of essentially decimal values for various values of x. And then notice that the equation needs a whole number of 1. And then, well, okay, let's just try 0, because even e to the power of 1 is going to give you something that's not going to result in a whole number. So you get 0 plus e to the power of 0, and we know that e to the power of 0 is 1. So then you get 1 equals 1, which works out. So essentially, that's your answer. Tricky, but you just gotta look at it. But maybe this is not how they want you to do it. Yeah, if you were to plug in 0, you get 4. In here. Because you get 3 plus 0 plus e to the power 0, so it's 3 plus 1, which is 4. Yeah, the tough part is, like, they told you to switch x and y. Yeah, I know. That's to find an inverse function. Yeah. I know what you mean. That's to find the inverse function, but we're just finding a particular value. So I don't know if it's even possible to algebraically find the inverse of this. Of this right here. Like, you know it's gotta be 4, and then you just think about what x value would work. I wouldn't recommend it for this question. Like, unless they explicitly say find the inverse function, that's when you should be doing your, switching of x and y and solving for y. But that's not what they want here. They want... But then isn't that just g of 4 equals 0 and not g inverse? No, it's backwards. G of 0 is 4. And then that's exactly the same meaning as g inverse of 4 is equal to 0. Because if I plug in 0, I will get a result of 4 in this function here. The tricky part is this. You needed to eyeball this and then know what x value it is. Okay. So I'm going to fill up the rest of the time, aside from helping out people in chat. I finished this AP exam. So if you were actually tuning in for the AP part, thanks. And I'm going to... I told my kids actually that I would go over this quadratics package that I gave them. And it's IB focused. But, you know, it's pretty general that you can apply it to any curriculum that has quadratics. So this dude, Christos Nikolaidis, if you are an IB student and you haven't heard of him, then get to know him really well. He has an excellent repository of practice, and I gave this quadratics package, and also linear, but I'm going to skip the linear part, to my kids. And then I'm just going to go over this for the next hour or so until it's time. And these should be quick and easy. It'll probably take me more time to copy and paste these than to think about what I should be doing. By the way, since the function is increasing, you can easily guess where the 0 is. Maybe that's what they want. Like plug in 10. Say that output's a number too high, you plug in a lower number. I guess. Like from what I can tell, they just wanted you to solve that through inspection, essentially. And then you can do what RGPT said, and like you start at a number 10, plug in 10, and then if they want her to show work, it's an online assignment though, so whatever. They just care about answers. Yeah. Okay, let's factorize this. Easy peasy. -5 and +2. Therefore, if we want to solve this equation equal to 0, then that means that it needs to be 5 or -2. Should I even do homework or just start the quiz? That's up to you. Paste. I think you're getting ahead of yourself though, because this is the start of a calculus course, and I don't think they've talked necessarily about increasing, decreasing functions, especially in regards to inverses and whatnot. Anyways, okay, here we go. Here's a function. We have it in factored form, p and q, x minus p, x minus q. Write down the values of p and q. Easy. You can see from the graph where your p and q values are. So p is -1/2, q is 2. And then the function has a minimum value at c, so this is where your vertex is. Find the x-coordinate. The x-coordinate should be in the middle of -1/2 and 2. So we just add these two values together and then divide this by 2. So this is 4/4, so this is 3/2 divided by 2. So 3/4. How do you do this? Yeah, what do you mean? What do you want either me or him to do this? Like find the inverse? Find the inverse of y is equal to e to the power of 1 minus x, like this? Or is it minus x outside of the e? Because if it's this, then you just change this to logarithmic form. So this says that the natural log of y should be the exponent 1 minus x. In other words, x is going to be the natural log, well, 1 minus the natural log of y, and then you do your switchy thing. So the important part is you need to be comfortable changing it to natural log form. Okay, so here's another quadratic. It's in general form. We need to find both intercepts, and then you find the coordinate of the vertex. So first you should probably check if it's factorable, which I think it is. X minus 2, x plus 1. So your x-intercepts are at negative 1 and 0 as a coordinate, and 2 and 0. And then we need to find the x-coordinate of the vertex, so this is exactly like this question. We know the vertex needs to be in between negative 1 and 2, which is like 0.5, but let's just show the math. Let's add the x values together and divide by 2, so then that's 1 over 2. Okay, here we have an upside down parabola. We have the points A, B, and C. They're the x-intercepts, and then B is the maximum point. Then we need to find all 3 coordinates. Okay, well, let me write this a little larger for y'all to see. But you know your A value is related to negative 1. And then this one is 7 for the x value. So this one is 7. So A is going to be negative 1 and 0. C is going to be 7 and 0. And then to find the maximum point B, the vertex, well, first we're going to find the x coordinate. Just like the previous questions. So the x value is going to be negative 1 plus 7 divided by 2, which is 6 divided by 2, which is 3. So for part B, or coordinate B, our x value is 3. And then to find the y value, well, I know what the x value is, so I can just plug it into the function for y. So y is equal to 7 minus x, which is now 3, and 1 plus x, so 1 plus 3. So this is what, 4 times 4? Which is the value of 16. Man, these questions are so easy. Especially compared to the AP Calc ones. coolest thing I saw in my first analysis course was showing that the Dirichlet function was not integrable. That sounds like a blast. RGBT is just on another level compared to everyone else on this stream right now. I appreciate your passion for math, and I wish I had as much of a passion for advanced math as you do, but I don't. Okay, this diagram shows part of this graph. And then we know the graph cuts the x-axis at here, so here's my x-intercepts. And then we need to find the value p and q. P and q are different than the p and q. If you're one of my students, these p and q's are not the same as the p and q's in the factored form, like this one right here. So try not to get that confused. Okay, one thing you note is we do know that the leading coefficient a is 1. So in factored form, I know that it should be x plus 2 and x minus 3 because those are my x-intercepts. And then if we just expand this out, excuse me, then you'll get the generalized form. And then that will be the p and q in the question. So that's x squared minus x minus 6. So here's your p. P is -1. Your q, -6. Yeah, I'm sure there's something like once you find it and you like it in math, then that's what you can start to get passionate about. Lukey the Pookie, thanks. Yeah, the cubic formula is interesting. It has a lot of history behind it too. And then that's like essentially from my understanding, that's where like complex numbers started to show up. So that's kind of cool. Like, don't get me wrong, I think advanced math is cool, but I have neither the desire nor the time to pursue it. There's a lot of things in life that I want to do, and yeah, I can't dedicate it all to math like some people can, which is respect to them. Okay, let's see. Here is a graph. I'm going to zoom in because I just need to fill in a table. And then we have A, B, and C, and then we need to complete this table. So here you can see our parabola is opening downward, so my A value needs to be negative. Love that for you. My C value is essentially the y-intercept. You can see right there that it's a negative value, so that's also negative. B squared minus 4ac is the discriminant. This has to deal with the existence of the roots. We have, as you can see here, one real root, which equates to the discriminant being 0. Okay. And then last but not least, what is B? Now B is the tricky one because B doesn't really have any particular qualities showing up in the graph itself. But we can work with this. So we know one thing. B squared minus 4 times a times c needs to be equal to 0. And we know that a is positive, and we know that c is positive. Does this help us in any way? Probably not. But that essentially means that b minus some number. Oh man, I went over this with a student the other day. B0. We'll come back to this one. So here's another parabola. Write down the x-intercepts. Okay, so we just need to factor this and then solve. There's a common factor of 2x. So then if you factor that out, you get here. So you can kind of see we have an x-intercept at 0. And the other one is at 4. Oh, I can't tell if you're asking me or someone else. What question are you even asking? How is the logarithmic function log bx defined? Like what does the question expect you to answer with? Like what's the format of the answer? Is it like a number or what? How is it defined? Like, are you allowed to type in a sentence? Like, what does it want from you? Yeah, a sentence? Why don't you just copy what RGPT says? Then it asks for domain and range. Are you sure it's not how? Are you sure it's not asking where is it defined and not how is it defined? Because domain and range is easy. Domain is it needs to be x needs to be larger than 0. And then I think the range is all real values. How to change log into an exact value? It's 3 parts to one question. How to change log into an exact value? This is the domain and range. But I don't know what they want from you, asking you how it's defined. I mean, You can say where it's defined, that's easier. But how is this defined? That's kind of a weird question. Anyways, continuing on. Axis of symmetry, 2, because it's in between 0 and 4. Y-coordinate of the vertex means I plug in the x value 2 into the function. So then I get, what, 8 times 2 minus 2 times 2 squared. So that's 16 minus 8, which is 8. So this is 8. Is that for all log functions? Yeah. Well, most. Aside from like if you move things around. Like the way that I would define this is like this basically means you're taking b to the power of y and then you're getting x. They're inverses of each other. I don't know. Why don't you try typing this function is the inverse of this function here, and then see if that works. Okay, here's another one. Parabola, factored. Let's see. The graph passes through these points. So right here, and right here. So find the value of Q and R, it says. So Q and R are related to my x-intercepts. So Q, let's say, is -2. R is 4. Write down the axis of symmetry. You can kind of eyeball it right here. It's 1. X equals 1. And find the value of P. P is this value right here. So for that, we need to do a little bit of algebra. So currently, as it stands, here's what my function looks like. I don't know what P is. And then I have x plus 2, x minus 4. And to find P, what I'm going to do is I'm going to take this third coordinate that I haven't used yet, my y-intercept. And I'm going to say that those are my x and y. So I know that this is -4 is equal to P, 0 plus 2, 0 minus 4. So from here we can find out what P will be. So we have -8 times P. So P is 1/2. Okay, and then now we move into just some discriminant stuff. Here's my quadratic equation. K is positive. Find exactly one solution for x. So in other words, one solution means my discriminant is 0. I don't know how to say this name. En Farouche. Thanks. And then we need to find K. So K is related to our B value. Our B value is 4K. So we have 4K squared is equal to 4 times A. A is also 4. And C value is 9. And this needs to be equal to 0. So let's see, 16k squared minus 144, I think. And then we got k is equal to 144 divided by 16, which is 9, k squared. And then that also means that k is going to be 3. And we do not consider negative 3 because they told us k is positive. Yeah, I should change the bot, like its tolerances. But I had it a little bit higher because the first couple of streams I was bombarded with ship posters in my chat. Chinese dudes. I'm not Chinese. Are you Chinese? That's racist. I ain't Chinese. You're Chinese?
Still racist.
That don't mean I'm Chinese. What am I? I'm Canadian. Don't you hate it when they ask you where you're from? I was born in Ontario. Okay, let's see. This equation has exactly one solution, so exactly the same thing as before. Just now, k is related to my a value. So again, one solution. That just means our discriminant b squared minus 4ac is equal to 0. Yes, I was born in Ontario. And then I moved to where I am right now early in my life. So 3 squared minus 4 times a times c, which is 1, so I'm not going to bother writing it. This one's easier than the other one. I don't know if I can say this on Twitch, but white men dominate the field of math by far. Yeah. Well, I mean, depends on how you define white men. But yeah, they do dominate every field. Like, are you also including, like, you know, all the European men as well? What about math god Terry Tao? He's not white. Yeah. Yeah. I know he's one guy, but he's the math god. Alright, so then let's find k. K is going to be 9 over 4. If you go to a math department, there's so many white guys. I guess. I'd say half of my professors were white men, and then the other half were everyone else. Well, RGBT, you're going to make a difference, right? You're going to be that Chinese math professor. Way to break stereotypes, right? Do you ever use a piece of paper and then erase everything so that you can reuse it? Yes.
Why?
Because I am environmentally conscious.
We have so much scrap paper. You're using all the rubber.
All right, let's keep going. So now this has 2 equal roots. So in this case, we know our discriminant. Again, 2 equal roots essentially means one solution. Yeah, I know both you and me are breaking all sorts of stereotypes, right? Being Asian and being good at math. So here's your A, here's your B, here's your C. 2 equal roots means your discriminant is 0. I believe in you, Twitch boys and grills. Yes. Okay, here we go. Easy peasy. Oh, by the way, RGBT, now that I know that you're Asian and you're good at math, do you, by any chance, have glasses? Who said you're good at math? You're better than everyone else on this channel so far. Okay, we solve for k. So what happens is after you put your a, b, and c values in the discriminant and setting it equal to 0 because you have two equal roots, you have this second quadratic in terms of k. So we just use our general quadratic knowledge and solve this like before, but k squared minus 10 k plus 9 equals 0. You sometimes wear them, but very rarely. Are you also skinny? Very skinny. I'm imagining a very nerdy, skinny Asian guy. And then from here, we can try to solve for k. I think it's factorable. Not super skinny. Skinny fat. And then here you go. 9 comma 1. Guess what I look like now? What do you mean now? 145, 140, and you're almost 6 feet? You're a little on the skinny side. A little on the skinny side, I would want to say. Well, oh, you want RGBT to guess what you look like? That's weird. I'm just a normal guy. Okay, write down the values of k so that this thing has two equal roots. Find the possible values of k. Write down the values of k. Oh, they're different oh, these are different. Why is this a part B? This has nothing to do with part A. That was a bad joke. Oh, well, okay, we repeat the process again. A is 1, here's your B, here's your C. And again, we want two equal roots, so the discriminant is equal to 0. All adults look similar most of the time. I don't know what to say to that. Besides, I don't know. I don't know if that's necessarily true. I strongly disagree by counterexample. Well, I mean, you can't counterexample a mostly statement. Except for those super jack guys, nerdiness and jocks seem to disappear. No, I don't think they disappear. Yeah, they don't care about it as much, but let me tell you, when I'm walking down the street, sometimes I'm like, damn, that guy, hella nerdy. And they're adults. Oh, especially if you go to like an anime convention. Then I'm just like looking around at everybody, and I'm like, everyone's hella nerdy here. Okay, let me get this one started. B squared minus 4 times a is 1 times c is k now. What the hell? It's the exact same discriminant. Okay, whatever. Next one. RGPT, you missed it. I'm gonna be a Twitch affiliate next time I stream on Thursday. Are you gonna subscribe? Do you have Amazon Prime? And do you have an idea for a good emote, Twitch emote, for my subscribers? Anyways, consider this function. This equation, when it's equal to 0, has two equal roots. So once again, our discriminant is equal to 0. And then we need to find out what k is, and k is related to a, b, and c. Yeah, you're younger than me by 4 years. But I guess you've been stuck in like academia, math academia, so you're less in tune with, I guess, current pop trends. Congrats. I think that means you get money. It does. I believe I get some ad revenue and people can subscribe to me. And essentially, it's like a monthly subscription, and what you get is you get special perks related to my channel. Yeah, and I do get to hang out with younger people, though. Not by choice. Yeah, I know you don't have money. But if you have like a Amazon Prime, then you get a free subscription to one channel. Okay, so this is all the same. These are getting very repetitive. But, oh well, I'll just go through them. Now, Tayo, I checked him out. He's super cool. Super cool guy. And I wouldn't, no, not a traitor. We don't even overlap. And like, he's magnitudes better at math than I am. So I don't blame you. I don't blame anyone. How do you find this inverse? Classic question. This one requires a little bit of algebra skill. Yeah. But yeah, Tayo's super cool. I followed him, but I'm not going to subscribe. Okay, Jazz, does your prof tell you to switch x and y first? Or do they tell you to solve for x and then switch it afterwards? Not that it really matters, but I want to stay consistent. Switch it first, sure. Okay, so we do a little switchy. And then essentially, the process to find the inverse is you need to isolate your y variable because you want it written, you know, like a function y equals. Now, you have two y's. One of them is in the denominator, so before we even consider trying to solve for two different y's, we should get it out of the denominator. So you multiply this over to the left side of your equation. So what you're gonna get is this. Yeah, we'll deal with that later. And then from here, we need to collect our y terms together. So to do that, we need to multiply our x in here. So you get x times y plus 8x. So now I can collect my y's together on one side of the equation. So I move things around, and this becomes a minus 4, and this becomes a minus xy. You got to jail? Look, I'm sure the actual question says that y cannot be equal to -8. Again, you're being overly pedantic here, RGBT. I'm sure they cover their bases in the question because there's going to be some smart ass kid like you who's going to be like, oh, well, you forgot about the -8 value because then you're going to go to jail. And yeah, I'm sure it was mentioned in the question. But anyways, Jazz, back to this. Collect your y values. Whatever. Doesn't matter. Fine. Once you're here, you can't divide by 0, so you gotta say this can't be 8. Not that any of that really matters. I mean, you don't have to, but it's probably the best. It's a reliable way to do it. I don't want to say it's the best way, but we're in the process. So, here. Now, normally, if these had proper coefficients, like for example, 3y minus 5y, then you can collect them together as 2 minus y. The issue here is you have a coefficient of x. So the way that you quote unquote collect your y's together is you factor it out. So this becomes y times 1 minus x. Because this essentially does the same thing. We collect our y terms together and we get one term with a single y. So it's easier to isolate. And then on the left side, we have 8 minus 4. So then here's your inverse. And then you want to find, and then this is, of course, we can change this to f of -1 of x. So then to answer your question, if you want to find the inverse, inverse at -2, then you just plug in -2 into these x values here. And then you have your answer. You did it. You mean I did it? Okay, continuing this one. Here are your k values. Well, okay, it says k can't be 0, so here's your k value, singular. You did the easiest part. I'm getting a little tired of lo-fi. I don't think I can get flagged for video game music. Whoa, whoa, whoa. I see 2 people. Oh, is the lo-fi too quiet? I hear 2 people taking credit for my work. I did it? Thanks, guys? Plural? Guys? There's only one guy involved in doing that question. Me. Okay, so continuing. The line y equals p intersects the graph of f. Find all the possible values of p. Can you hear it at all? Can you hear it now? It's really loud in my ear. Man, have I been speaking to you guys without music this whole time? Hold on. Let me turn this up. How about now? Is it too loud now? This seems very loud, but I can't tell. It's different for me than you guys. Yeah, there was music this whole time. I don't know, the audio settings are always weird. Okay, this particular question is so oddly worded. Essentially, now that you found out what k is, it's 1/2. You know what the parabola looks like. First off, it has 2 equal roots, so for part B, you need to know what the parabola looks like in general. Because it has 2 equal roots, that means that the vertex is on the x-axis. Because the k value is 1/2, we know that the leading coefficient is 1, which is a positive number. In other words, your parabola opens upward. Okay, I'm going back to lo-fi. I got tired of it, but that was even worse. Serpent, thanks. So here's what your parabola looks like. And then it says that we have a horizontal line at some value p that intersects the graph. So the line has to go through the graph. So the line can't be down here, y equals p. And then we need to find all the values of p. Essentially, we need to find out all of these values of p, like 1, 2, 3, 4. Any value of p that's going to intersect the graph. In other words, this is a very fancy way of just asking, what is the range of your function? So give that some thought. Like, for example, y equals 0 will intersect the graph. Y equals 1 will intersect the graph. And so on and so on and so on. Even decimal values. So essentially, this is a very fancy way of just asking what's the range of f. And we know what the range of f is because we know what the parabola looks like. Y needs to be greater than or equal to 0. You don't need to apologize. Okay, well, you type it out, and then let me finish this one. This equation has 2 distinct real roots. So in other words, you know your discriminant needs to be positive. And then we need to find your values of k, so typical setup. Here's your a, b, and c's. So you have negative 2k squared minus 4 times a times c, but they're both 1. Excuse me. Okay. This is the function, but what's the question? So while you do that, I've set up my discriminant. I need it to be positive, larger than 0. And I need to solve this for it being larger than 4. So there's a couple of ways to do it. Let's do this the intuitive way. Essentially, after you're doing a little bit of algebra, you know that k needs to be larger than 1. In other words, k needs to be larger than 1. Well, k squared needs to be larger than 1, or k needs to be less than -1. When you square values that are larger than 1 or less than -1, the squared value will be larger than 1. So here it is. Okay, so back to Jazz's question. What do you got? We got a function. And it's the absolute value of x multiplied by x. So what's the inverse if x is greater than or equal to 0 and if x is less than or equal to 0? Okay. Okay. When you're dealing with inverses, you need to change them into a form that you can do, algebraic processes on, because an inverse isn't super great to isolate for x. Now, essentially, you got to remember what an inverse does. If the thing inside the inverse is negative, it turns it positive, and if the thing inside the absolute value is positive already, then the brackets don't do anything. So that's why we have to split this up into two situations. One where x is positive, and one where x is negative. And that's exactly what they did in the question. So first, if f is positive or 0, then the absolute value of x doesn't do anything because it's already positive. There's nothing to do. So what we can do is we can write your function f of x as just a regular x times another regular x, so x squared. Ballo 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 ba, thanks. And then you can find the inverse of this pretty straightforward, so I'll leave that to you. And then the second situation is if your x is negative. If your x is negative, then the absolute value brackets turn it positive. So we can write that like this instead. To turn this x, which is negative, into a positive, then we can just write a negative in front of it. So this is what the absolute value does, essentially, if it was negative. So our full function, of course, is this is the negative x part, and then we just need to include another x over here. So in other words, your function is negative x squared. So yeah, you find the inverse for each one. Does that make sense? Why is it negative x? Because if x is negative, right? That's why we broke it into two situations. If you know x is negative, then the absolute value needs to turn it positive. So we just multiply it by a negative. So this turns this into negative, or I mean positive whatever. You have to teach tomorrow? What do you mean? What kind of advice do you need? I need you to prepare me mentally. Well, what are your concerns about teaching? Pep talk? Yeah, just have fun. Show them your passion. They appreciate it when their teachers show passion. Okay. Oh, so Jazz, what we're doing is we are replacing this with something that does the same thing. So I'm replacing absolute value with this negative sign, because the negative sign does the exact same thing. It's not that I have an absolute and then I'm adding another negative. Like when x is positive, I replace it with nothing. It's just a regular x because the absolute value doesn't do anything. But when x is negative, I replace the absolute value with a times by negative because that does the same thing. Yeah, just have some fun. Troll some kids. What are you teaching them? Linear algebra? That's fun, right? Matrices and stuff? Okay, what is this? Find all possible values where the function crosses the x-axis. In other words, this means that we have a discriminant and it's equal to or bigger than 0. So we have our discriminant, which is going to be this, and we need to find it larger than 0. It's not like an honors course, it just like focuses on applying theorems and definitions. It's pretty dull. Dull for you, maybe not dull for them. This is where your personality shines through, and then this is how you have fun. Yes, but I care about me. Well, do you think I have personality? Yeah, sort of. Everyone has a personality. Asshole personality? No, I don't think so. I should be playing video games and not teaching. Not a teacher personality. There's a lot of personalities that could be teacher. There's not like one set teacher personality. Like, I don't think my personality is a stereotypical teacher one. Like, I have no idea how you teach, so I can't say. But, you know, worst comes to worst, just think of the money you get for teaching tomorrow. And think of all the nice things you can buy, like a sandwich for lunch. Okay, so I put this into here and then I solved it. So as long as k is larger than 9/4, which is I think 2.25, then it works. So here are the possible values of k. These are the ones that work. Yeah, I think we had this talk before about your expectations. As a pure, you know, math student, of course your expectations are high, and you gotta lower them because a lot of these students are just kind of going through the motions and taking your class because they need it for their degree. Yeah, and as long as you do your part, it's fine. If like you made it as easy as you think you could have, then that's all you can do. Because, like, at the end of the day, they still need to come and meet you where you expect them to meet you. So if they still don't meet you after you've lowered it, then that's on them at that point. And then if they can't meet you, then you fail them. See you later, kid. So basically, what he's saying is that you got your students, right? Then you got him. RGPT. And then normally, you know, you compromise. And you meet each other halfway. But this is too difficult for the students sometimes. So what he does is he lowers the bar, and then here's the expected place to meet them. Except the students still can't reach it. So that's what he's saying. There's an issue. And what I'm saying is, yeah, it's an issue, but it's not your issue, it's theirs. And they need to learn to deal with it. You put the bar behind the students? Well, look, if you think that they're hella lazy, then you need to have a chat with them. And be like, hey, I think you're hella lazy. And the way I've designed certain things, you are supposed to have no issue with it, but you are. So we need to have a talk about your expectations of this course versus mine. Yeah, I'm not a good motivator because I was always working hard in school. Yeah, I bet you were. I bet you were the kid that was like, if the teacher forgot to check homework, you were like, oh, excuse me, Mr. Whatever, but we need to check homework. And then the whole class hates you. Yeah, that is how uni works, so whatever, right? If they fail, that's on them. And like, you made it as easy as you think you could have, within reason. You were always the troublemaker? That's surprising, considering you're a math student. Okay, let's see this. Consider two different quadratic functions. This one... Oh, they both have this form, and then there's going to be two different q's. The graph of each function has the vertex on the x-axis. Find both values of q. So, having the vertex on the x-axis, again, is a very, very fancy way of saying one real root. So again, this is another discriminant question. And I need to find out where this is equal to 0. Yeah, you feel bad because you could be a better human and surpass the expectations of the university. That's unfair because you can't hold everyone to the same standard. I think that that's an unreasonable expectation on yourself. That there's always more that you can do as a teacher, right? And then you need to draw the line somewhere. And that line is different for people, different people obviously. Like my line is like, I'm okay with staying up and streaming to help with math, and I wouldn't be surprised if there's a lot of teachers that say that that's a little too far. And I don't know, you need to learn to draw where your line is for how much you can do for them. And if you think you can do more, then do more. If you don't think you can do more, then don't. And like, at least for you, you're in a university setting, right? Like if people fail, at least it's not your fault, it's their fault. So I don't know. If you're not happy with how you teach, then you should change it. But, you know, keep it within reason. Yeah. Look, there's so many issues with the educational system, right? And like you and me, we're just lowly peons in the system. And I don't know, try a little bit. Do a little experiment here and there, I guess, if you want to try something new, but like, what can you do, right? I'm on question 27 of the package. So here we are. And then to find out what q is, we know that there's two values. They tell you it's the square root of 400 plus or minus. And then for the greater value of q, we need to solve the square root of 0. Or sorry, for the greater value of q, we need to solve the function equaling 0. So for the greater value of q, well, that's plus 400. But essentially, we want to solve this. So the easiest way to do that is using a quadratic formula. Oh, hi Serpent. I didn't see that you were in here. How was your test or quiz? You had one, right? Weren't you here on Thursday and then you said you had a test? Or was that some other person with a snake related name? I don't remember. Not you? Okay. Anyways, if we use the quadratic function, then that's the full thing. X equals negative b plus or minus all of this stuff divided by 2a. Now here's the thing is, given the context of the question, we already know that all of this is 0. So this makes our quadratic formula much easier to work with. X is equal to negative b, which is negative root 400, divided by 2 times a, and then a is 4, so then we have 8. So you got negative root 400 over 8. And I'm sure you can simplify this, but oh well. And then let's see, find the coordinates of the point of intersection of the two graphs. Okay, so we have the two graphs. We have 4x squared plus root 400 x plus 25. And then we have the other graph, which is when it was minus root 400 plus 25. So to find their point of intersection, well, you set them equal and then you try to solve for x. Now what's nice is everything kind of cancels out aside from a few things. So you got root 400 over here, is equal to minus root 400 over here. So if you put them together on one side, you get this, which is 2 400s. So they intersect at an x value of 0. And then it wants us to find the point, so we gotta take this x value and then plug it into one of the functions. And then if you plug in 0, then anything with the x goes away, so the y value is 25. So here's your point of intersection. Jazz, how's your math? I feel like I'm gonna stop streaming soonish. So get your questions in while you can. RGBT, how's your hype? You ready for tomorrow? You ready to teach tomorrow? Okay, hold on. Hi, I don't mean to interrupt your teaching lesson, don't worry about it, but I had a question relating applying statistical principles to validate a strategy for a popular online casino game in order to make profit. Unfortunately, I have no mathematical background, I have no idea where to start or who to approach. Would you be able to help me and point me in the right direction? I would say that you need to go, of course, and talk to a mathematician who does have experience with probability and statistics. Because what I'm assuming is you have some strategy to some popular casino game, and then you want to see how good it works. So yeah, you would probably need to go and visit or talk to someone with math skills. And then, do I know anyone or know of where to go for that? I mean, yeah, I have math skills, but I hate probability and statistics, so, and I don't think I'm particularly good at it. And I have a feeling your strategy might be a little too complicated for what I think. I mean, like, I'm gonna do what RGBT recommends. This may or may not be a good place to start. I think it's better than anything that I could recommend. But there's another Twitch streamer. Oh shoot, what's his name? RGBT, are you here? Tell him the name. There's this other math streamer who is a graduate professor. And I think he might... Balaba needs a place to start asking questions. He has a strategy for some online casino game, and he wants to see if it's statistically or, you know, probabilistically valid in order for him to turn a profit. So I want to send him to Inoue, but I forgot his first name. Taiyo, right? Taiyo Inoue. Yeah, this guy. So he's like a 40-something-year-old Japanese math professor with a PhD. So next time he streams, maybe you want to hit him up with the specifics. But honestly, those casino games have, like, they're worked out and they know all of the statistics. And basically, if you're playing a casino game, the probability of you winning is against you. But, you know, maybe your strategy is that loophole. Yeah, good luck. And if it works, share the strategy, because I would also like to turn a profit. Okay. You are stuck on the last question. The absolute value one? This one? Don't even answer your question? Okay. Let me guess. You just need to find two different inverses. Okay, what is this one? We need to change this to this format so we complete the square. Easy enough to do. So to complete the square, I'm gonna need to add and subtract 9. And if we do, then we get x minus 3 squared, and then negative 9 plus 14 is plus 5. So then there you go. There's your h and k. And then hence or otherwise, write down the coordinates of the vertex. So the coordinates of that vertex are at 3 and 5. Okay, let's see. The expected value is negative, of course, but I was wondering if there's a way to take advantage of that, like in Parando's paradox. I don't know what Parando's paradox is, but again, expected value being negative means like you expect to have a loss each time, which is to be expected. It's a casino game. There's never going to be an expected value of you turning profit. And I don't know. I could look at Parando's paradox right now, but yeah, this is closer to like statistics, which is like, it's nothing that neither me or RGBT are familiar with, because that's kind of like a distant, not distant, but it's like a cousin of math, so we're not super familiar with it. But I would say, yeah, good luck with it, but you know, be skeptical. Because come on, it's a casino game. There's probably it's probably rigged against you. Anyways, Jazz, you don't know how to do the negative one? What's the big deal? It's the exact same thing, except now it's negative, right? So now you have negative y is x squared. And then I'm sure your issue is because you're trying to square root this, right? Well, actually, you do the switchy stuff first. It depends. You can't take the square root of a negative value, but just because you have a negative in the square root doesn't mean that the value is going to be negative, you know? So here, we do the switchy, and then you get this far. And and then you do the square root. Now here's the thing, is that if you were to look at this function right here, you need to consider the domain and range. And essentially, y is always negative. So that y is this x. So you need to have this negative in front of it to turn it into a positive value so that you can square root it. You did that and you got it wrong. Do you need to state the domain? Because the domain is, it works, but you need to make sure that you say that the x value is negative. No, just what the inverse is. Have you tried typing in the same thing and seeing if it works then? It gives the domain, it says that x is negative or equal to 0. Then, oh, it gives the domain, then it should be this. That's weird. Okay, let me just look at this real quick. So here's your function, right? And then we're looking specifically at this domain here. And then we need to take the inverse of this. Which would go this way. Oh. It should have another minus in front here. So try that out. It comes from when you take the inverse of any square root, right? Not even including this negative, like for example this. Well, the inverse is going to be y equals to square root x, except you need to consider both plus and minus. So for example, so if you have y equals x squared, right? Then the inverse is not actually a function, because the actual true inverse is x equals y squared. So you have a sideways parabola. This is not a function, so what you do is you split it up into two halves. You have the positive square root part, and you have the negative square root part. So hopefully you're okay with that. Then, for your specific example, we know that the inverse to this general function, not the inverse function, but the inverse, is y is equal to plus or minus the square root of negative x. And then you need to select which half you want. So we want this bottom half. So we need to choose the negative. Because your original domain is x is negative, and then that relates to the bottom half with the negative half. Because if it's positive, that's the upper half. But then if it is positive, then it's the other function. Okay, I'm gonna finish up this page, and then I think I'm gonna call it a day. And this page won't take me too long, so get your questions in if you can, or come back on Thursday. So here's a function. We need to express it in this form, and then we need to find the minimum value. Okay, so let's complete the square. First I factor out 2 from the first two terms, so that I know I'll get minus 4x. So to create a perfect square trinomial, I'm going to need to add 16 and subtract 16. So then the first three terms are going to be, oh whoops, not 16, plus and minus 4. I essentially need to take half of this, which is negative 2, and then square it to get my 4s. And then multiply the 2 in. And then we've converted this into vertex form. And then find the minimum value. Well, the minimum value is the y value of the vertex, which is negative 3. All right, last question. Write down the coordinates of the vertex. -4 and 8. Easy. Given that f at 7 is -10, find the value at a. So -10 should be equal to a times 7 minus 4 squared plus 8. So if I plug in my x and y values, and then I can solve for a. I don't have a Discord. I was too scared to start one because I don't want my students like trolling and putting inappropriate stuff. That's just extra work for me. I don't want to moderate a Discord. No, it's the opposite. They're the degenerates. Anyways, a mod Vincent -4. Is a -4? I don't think so. Hold on. I think it's -2, right? Vertex? What about the vertex? This is already in like a vertex format. The coordinates are, oops, +4 and 8. They're just whatever these values are in the formula. Oh yeah. Yeah, thanks for calling that out. Should be 4, 8. Oh, that changes my answer here. This should, actually, does it? No, it doesn't. Anyways, yeah. So find the value of a right here. And then hence find the y-intercept of curve f. Alright, final question. I don't know why they call it a vertex. This is called the vertex. Alright, to find the y-intercept, that means that I'm going to say that x is 0. Yeah, I'm sure for some higher up reason you shouldn't call it a vertex, but whatever, man. You're so pedantic. Alright, evaluate this. So that's -2 times 16 plus 8, -32 plus 8. It's the first time that they see the word, so it's not confusing because they don't know, like, you know, the other meanings of vertex. -24. Yeah, it's a bad name, whatever. What would you call it? If you could rename this so it's no longer called the vertex. The inflection point? The local extrema? Mountaintop? Mountaintop, valley bottom? Local areola. I don't know about that one. Okay, so here we go. Thanks, Vincent, for correcting me. Yeah, you sound a little repressed there, RGBT. A little, just a little bit. So yeah. Your local extrema. Extrema? Okay, you need to stop. Okay, good work, everybody. Streamed for a little bit longer than I wanted to, but that's okay. Thanks for tuning in. And next time, I will be an official Twitch affiliate partner. Well, oops, not partner. Twitch affiliate. Partner is the next step afterwards. But that is an unreachable goal because I need 75 regular viewers every time I stream to be a Twitch partner. But yeah, you're welcome, guys. Tune in next time, Thursday at 8 p.m. Pacific time. Otherwise, I don't know. Have a good rest of your night. We're 4% of the way. I don't think we'll get much farther. Good luck with your teaching tomorrow. Good luck with your assignment. Okay. And yeah, talk to you guys later. Bye.